Bismillahirrahmanirrahim. So today's lecture is on the design for test. So testing is one of the most expensive part of the chip. I think that everyone has heard Prof. Nohayati's talk on Tuesday. So actually testing is a very important part of chip manufacturing, and it is one of the most expensive section. So in order to ensure that the chip is reliable, we have to perform testing. So there is something known as logic verification, where you verify the logic of the circuit and whether it is working correctly. So logic verification accounts for more than 50% of the design effort for many chips. And the debug time after fabrication, if there is an error, it will cost a lot of money for the manufacturing. And of course nowadays, with all the chips being placed in important applications such as in the automobile, in important processors, if the chip is not working and if the chip is defective, it can destroy the reputation of the company. Okay, for example, Intel, they had a FDIV bug, and this error was not caught until they had already shipped 1 million units to the customer. And because of this defect, they had to recall all the chips, and the recall cost is even more expensive than the cost of the chip. So the recall cost was over 450 million. So testing is very important. So you have to ensure that the chip is good before you send it to the customers. So what is logic verification? Logic verification is actually to verify whether the chip is functioning correctly. So this is also done at the HDL level, or the hardware descriptive language level, and you can create a test bench using Verilog or VHDL code. And because if the chip has a lot of input and output, you cannot test all cases. So sometimes you test a certain number of cases. This can be random, this can be the corner cases. The corner cases are like zeros and ones, as all zeros for the inputs and all ones. And there are some certain functions where you need to test to try to see if the chip will malfunction or not. Okay, for example, in a 32-bit adder, you can test all the corner cases. Let's say all zeros, all ones. The inputs are 2. The input is 2 to the 31 if there is it's a 32-bit adder, minus 1, and 2 to the 31, and a few other random numbers. So testing is also requires expertise, and good tests require a lot of skills. Okay, the next part is the silicon debug. So the silicon debug is what you do when the chip has been fabricated and it has been complete. So you have to verify the chip. So if you are lucky, the chip will work from the very first design. So if not, you have to redo the test, redo the design if the chip doesn't work, and there will be several iterations. So there are two types of debugging or cause of failures. So one is the logic bugs, and the other one is the electrical failures. The logic bugs is because the chip was not simulated properly, and there was some problem in the design. So these are known as logic bugs. The electrical failures are failures not because of the design, but because of other factors. For example, crosstalk, dynamic nodes, charge share, where the transistors have leakage, there's charge sharing. Ratio failures means that the sizing of the transistors are not correct. So these tools have included certain checks such as the design rule check to avoid these kind of problems. So you can lay out the chip properly, certain wires properly, so that it can avoid crosstalk. You can have certain design rules so that the transistor or the line doesn't have charge sharing. Okay, so for the first run or the first prototype, you can test, and if there are errors, you can fix the bugs and fabricate a corrected chip. So how do you diagnose failures? So people normally diagnose failures by using Shmoo Plot. Shmoo Plot was developed by the person who was called Shmoo, and it is actually voltage or a voltage plot, and it can be varying versus frequency or different kinds of parameters. Okay, so what they will do is they will put the chip on a tester, and they will use certain methods to access different nodes on the chip. Because the chip is very, very small, you need something which is called like pico probes to access the little points on the chip. So for example, if you have a chip over here and there are many transistors inside, so the pico probe will access a certain node and a specific node that you want to test, and it is very tiny. Okay, so to access a specific node and to measure the current or the voltage, you can use pico probes, electron beam, or laser voltage probing. Alright, you can also have certain kinds of circuits which is known as built-in self-test circuits. These circuits will help you to observe the output at the output node. So for example, you want to test at this node, there will be a special circuit or wire which will pull out the voltage to the outside world. So this is your chip, and this is the outside world where you have your pins from the chip. Okay, so in the Shmoo plot, you can vary voltage versus frequency. So for example, here you have different voltage from 1 to 1.5 volts, right? And you can see where the chip fails. So this is the voltage, so 1 volt until 1.5. So you can see that here the dots are the ones that show that the chip is either failing, and that means there will be no correct output. So in this case, at the lower voltage it's okay, and at a certain point it will have failures. Okay, so it will only fail at a certain voltage. If you put in a voltage of between 1.2 and 1.4, the chip will fail. And there are different kinds of tests to do that. Okay.